Hi guys, good morning. Shall we start? Is everyone ready? So I think we were seeing I think energy profile diagrams, Arrhenius equation, isn't it? Right. So we saw a lot of things. We saw so many things from the energy profile diagram that we'll be able to get informations about so many things like I'll be able to predict whether the reaction is exothermic or endothermic, or say I'll be able to predict the number of steps, whether the reaction is going to be an elementary reaction or a complex reaction, and if it is a complex reaction, how many steps it will have, right? So I think all these things we saw last class, right? So today we'll do some problems, right, and then we'll go for a little more information about that energy profile diagrams with respect to if I give catalyst and all, what will happen. We'll see that later. So now we'll do some problems. Okay, take down the question. The rate of a reaction, I'm giving you a question, we're going to solve it, right? The rate of a reaction doubles when the rate of a reaction doubles when its temperature changes from 300 to 310 Kelvin. Temperature changes from 300 Kelvin to 310 Kelvin. Find the activation energy. Find the activation energy. Right. So they are giving you two temperatures. They are giving you how the rate constant is changing. Basically, they told that the rate is getting doubled means the rate constant is getting doubled. That's what you need to understand, right? And then they're given the temperatures, the rate is getting doubled, and they're asking you what will be the activation energy for this reaction. So guys, tell me, which formula will you use? Which formula will you use? Yeah, Arrhenius equation, correct? Arrhenius equation, what formula? There are two formulas, isn't it?
I think we use the second one, sir.
Correct. So if you have this equation, that is, when I have two different temperatures, right? When I have two different temperatures and how the rate constant is varying, that particular formula which you have to see. So I think the formula will go like this: log of K2 by K1 is equal to EA divided by 2.303 R into T2 minus T1 divided by T1 T2. So you know how this is derived? Nothing. So I just had the Arrhenius equation. I took log on both sides, and then I put T1, K1, T2, K2, subtracted the equation. I got this. Right? Go for the formula. Tell me the answer. R value, you know how it should be, right? R value should be 8.314. Temperatures, two temperatures T1 and T2 are given, right? So log of K2 by K1 will become what? Log of K2 by K1 will become what now? Hello. What is happening to the rate in this question when the temperature is increased from 300 to 310 degrees, I mean 310 kelvins? What is happening to the rate?
It's doubled, sir.
Correct. So rate is doubled. So what will happen to K2 by K1? When the rate is doubled, a rate constant is also doubled. So I can say that I can write K2 as 2K1 by K1. Isn't it? The K1 was the initial when I have 300 Kelvin. Now when I go to 310 Kelvin, it is becoming doubled. That means K2 value will be equal to 2 into K1. So obviously, I'll be able to cancel this out. So I'll have only log 2 in the left hand side. Right? Continue. Tell me the answer. I hope everybody is trying the problem. Do not sit idle, please. Solve the problem and tell me the answer. Yes, any answers?
Sir, I'm getting a very big answer, sir.
Yeah, it should be. It will be in terms of kilojoules. So, anyways, tell me the answer.
It's 53,603.538.
Good, good, good. Yes, that's the answer. Very good. So it's basically I can tell it as 53.6 kilojoules per mole. Can I tell it like that, Kana? You're telling 53,000 something, right?
Yes, sir.
So it should, can I tell it as 53 point something kilojoules per mole?
Yes, sir.
Right? So yeah, cool. So simple formula substitution. So now we have substituted this. EA is what we have to find. 2.303 into 8.314 would be there. And T2 is 310 minus 300 divided by 300 into 310. This is what we would have had. So log 2 value is 0.3010. Okay. So if I bring this up into 2.303 into 8.314 divided by, okay, this would have come to the numerator 300 into 310 divided by 300 minus 310 will become 10. So yeah, so you must be, if you do the calculations properly, you should be approximately getting the answer as 53.6 kilojoules per mole. Always remember, whenever you write the unit for activation energy, it should be in terms of joules per mole or kilojoules per mole. Per mole should be present, right? So hope you know why are we doing this per mole. Do you know this? Not only in this, no, you would have seen this per mole coming even in your enthalpies or activation energy here, even in your internal energy in your thermodynamics, right? So do you know what is the specification? What is the importance of putting this per mole? Do you know this? Any idea or any guesses? Why am I putting per mole in all these energy values? Okay, so I suppose that you don't know. So please understand that the energy values, not only this, any type of energy for that matter, are extensive properties. Hope you remember what you studied in 11th class: extensive and intensive properties of thermodynamics, right? So we know what is the difference, right? Extensive properties are going to depend upon the amount. Intensive properties are independent of the amount. Okay. So it is always good to work with intensive properties, because if amount changes, if the value changes, like it's not good for my calculations. So it's always better to have intensive properties, right? But all your energy values, right, in terms of enthalpies or activation energy or whatever, all these will be extensive properties. All these will be extensive property. So I told you that going with intensive property is better, right? So what I can do is, there is a way by which I'll be able to convert an extensive property into an intensive property, right? I can convert an extensive property into an intensive property. Very simple. So I just have to do this. Divide the extensive property by the number of moles, right? Divide the extensive property divided by number of moles. You will be getting the intensive property. Now are you understanding why am I putting per mole here? So basically, by dividing the extensive property by number of moles, I am actually making sure that the amount is constant, and the constant amount is 1 mole. Are you able to understand? Are you trying to get what I'm saying? So basically, extensive property will change if the number of moles changes or if the amount changes, right? So if I divide that by the number of moles, it becomes an intensive property, right? Why am I making it? How it becomes an intensive property? Because the amount is now constant. The amount is now per mole. For 1 mole, this much. For everything, we say per mole, per mole, per mole, making sure that it becomes an intensive property. Anyways, like this and all are little extra knowledge. We'll go to the next problem. So 53.6 kilojoule per mole would have been the answer. Okay. So one more. So there is, all the questions will be like this only, guys. Basically, they will give you the temperatures. They will give you how the rate is changing. And they will ask you the activation energy. I'm looking for a different type of question. Okay. So they've given something like this. So they've given K is equal to 4.5 into 10 to the power 11 e power minus 28,000 K divided by T. Okay, so they have given this equation. K is equal to 4.5 into 10 to the power 11 into e power minus 28,000 K divided by T, right? So they want to know what is the activation energy from this equation. Can you calculate and tell me?
காலைல பயந்துட்டே பிடிச்சிச்சா அடக்கிட்டு இருப்பானே எனக்கு காலைல அவங்கிட்ட விளாடக்கூடாது நீங்க உட்காரனே பிசிச்சான்
Whomever it is, please mute yourself, please. Okay, so now how will you approach this question? Right? So it's simple, right? I know how the Arrhenius equation looks. K is equal to A e power minus EA by RT. Correct? Right? So now can I say this particular value which is here, which is what is my A before the exponential? Correct? And then e power minus EA by RT. Now here I have e power minus 28,000 divided by T. E power minus 28,000 divided by T. So can I tell that if I take a minus also gets cancelled. Say I just say that minus I'll not take. So can I write this as EA by RT is equal to 28,000 divided by T? Can I write it like this? I'm just comparing the equations. This equation and this equation I'm comparing, right? So I know A will be this. E power minus 28,000 divided by T is there. So I can write, though basically that should be equal to EA by RT, or minus EA by RT is equal to minus 28,000 divided by T. Correct? So I can easily cancel T and T. Correct? So what will be the EA value? EA value will be 28,000 into 8.314 would have been the answer. Yes, what will be the answer? Did you calculate?
Sir, 232792.
Yeah, correct. So it will be 232.792 kilojoule per mole. Right? It will be 232.792 kilojoules per mole would have been the answer. Right? Okay. So this kind of questions can come in 1 mark or say 2 marks. They can give this kind of equation, Arrhenius equation. Just compare and get the answer out. Okay. Right. One last question, then we'll go for the concepts. Okay, your next question. For a reaction, the value of K for a reaction, the value of K is 4.5 into 10 to the power 3. The value of K is 4.5 into 10 to the power 3 per second at 10 degrees Celsius. At 10 degrees Celsius. Right? And okay, and the activation energy is 60 kilojoules per mole, 60 kilojoules per mole. At what temperature K would be, at what temperature K, that is rate constant, would be 1.5 into 10 to the power 4 per second. At what temperature K, that is rate constant, would be 1.5 into 10 to the power 4 per second. Right? So again, the previous formula. So they are given the two rate constant. They are given two rate constant values, right, and one temperature and the activation energy. Now, what you have to find? You have to find what will be the second temperature at which the K value is this much. Right? Go for it. Use the formula. Tell me the answer. Quick.
Sir, could you repeat the question?
Yeah, sure. So I'm telling, for reaction, K value, the value of K is 4.5 into 10 to the power 3 per second at 10 degrees Celsius. At 10 degrees Celsius, and the activation energy is 60 kilojoules per mole. 60 kilojoules per mole. This is the activation energy. So they're asking at what temperature K would be, that is the rate constant, would be 1.5 into 10 to the power 4 per second. At what temperature the K value will be this much, 1.5 into 10 to the power 4. And if you do the stupid mistake of substituting the temperature in degrees Celsius, I know at least one of you would have done for sure. Please put the value of temperature in terms of Kelvin. If you don't do that, the entire problem is wrong. So 10 degrees Celsius would become 283 Kelvin, right? In the same formula, right? Log K2 by K1 is T1 minus 1 or T2 minus T1 by T1 T2, anything. I think if you keep it like this, it is little easier. The calculation will become little easier if you keep it like this. 1 by T2, 1 by T1 minus 1 by T2. Is any answers? Right. So log of K2, K2 is 1.5 into 10 to the power 4 and K1 is 4.5 into 10 to the power 3, which is equal to activation energy is given 60 kilojoules. So it should be 60,000. Remember, 60 into 10 to the power 3 has to be substituted here in terms of in your activation energy. It's 60 kilojoules, so it's 60,000 or 60 into 10 to the power 3. Okay, so divided by 2.303 into 8.314. I don't have space, I'm writing it down into 1 by T1. T1 is 10 degrees Celsius, so it is basically going to be 283 minus 1 by T2. So this T2 only we have to find. Done. To make the calculation a little easier, you can first before doing any calculation, you just calculate 1 by 283. Okay, so 1 by 283 0. Okay, 0.001 more. Okay, so I think it's 3 times 0.003. So this into 3, 600, 840, 840, 849. So 849 will become, I think, 151, again 0. If I put, it is going to be around 849 plus 200 will become 1000. Say 4 times, 5 times approximately, right? So I can write this as, again, this if I calculate, this will become 1 by 3. So 1 by 3, and I have 10 in the numerator, right? So I can write this as log 10 minus log 3. I can write it like this, right? I have 10 power 4, 10 power 3. I have 110 in the numerator, right? So I have log 10 by log 3, or log of 10 by 3. I can write it as log 10 minus log 3. Okay, is equal to 60,000 divided by, and this into, and this value I found out to be 0.0035 minus 1 by T2. Done. I did the calculation. 1 by 283 is 0.0035. Okay, right? So now log 10 value is 1, log 3 value is 0.45. Okay, so 1 minus 0.45 will become, I think, 0.55 into 2.303 into 8.314 divided by 60,000, right, is equal to 0.035 minus 1 by T2. Okay.
Sir, is the answer 297?
Yes, yes. The perfect answer is 297 Kelvin. So you would have found, if you do the every calculation properly, obviously it will take some time, but if you do it properly, you will be getting the answer as 297 Kelvin. That's the answer. Okay. So yeah, if it is like competitive exams, you'll be able to approximate and tell the answer. But since it's your school, like we will not be able to do it like that, right? You have to calculate each and everything properly, and that's why you're given step marks, right? You are given step marks just for the maybe the calculation, the formulas, units, all these things matters. Okay, so the answer would have been 297 Kelvin if you would have calculated properly. Okay, right? So yeah, so this is how questions can be asked from your activation energy and say the Arrhenius equation. Okay, so we'll try to, yeah, that's it. We are almost at the end of the chapter, guys. Right after this, I think I will be teaching you only one more chapter, or two more chapters. Surface chemistry is over, guys. Is surface chemistry over for you? Hello?
No, sir.
Oh, surface chemistry is not over. So I will, after this, I will have two more chapters for me to complete in physical chemistry. One would be solid state, the other would be surface chemistry. Right? So both these things I'll be completing. And rest all chapters, I think that ma'am will take. Okay. Okay. So we were talking about catalysts, right? So we know catalysts increase the rate of the reaction, or say catalysts generally are of two types. So one are what are called as promoters. So catalysts can be of two types. So or one are what are called as promoters, and the other ones are what are called as poisons. Okay. So it's all about whether they are increasing the rate of the reaction or decreasing the rate of the reaction. So please understand that promoters are the one which will increase the rate, and poisons will decrease the rate of the reaction. So how can I give you any example from organic? I can take examples because you would have seen so many reactions there. You would have seen this reaction, right? CH2 double bond CH2. If I put H2 palladium poisoned with BaSO4, I know I'm going to get CH3CH, right? But same thing if I put H2 bar nickel, H2 bar nickel, same answer you'll get, right? So in this case, nickel is going to be my promoter because it increases the rate of the reaction. But this whole thing, that is palladium with BaSO4, is actually a poison which will decrease the rate of the reaction. Okay, so this BaSO4 especially, basically, PD is the catalyst, proper catalyst. It is going to increase the rate of the reaction. But this BaSO4, which is used here, is basically going to be the poison which will decrease the rate of the reaction. Okay, so like this, there are so many things which are there. Okay, so we will be studying about this in a detailed manner if I go to surface chemistry. I have a separate separate course, right, which will talk about catalyst in surface chemistry. Okay, so we'll talk about that in detail, the types of catalyst, or like say the mechanism of how they are doing it. All this we'll see in surface chemistry. But for now, I will just speak in terms of the rate aspect because we're talking about the chemical kinetics here. So let me talk about the kinetics. Okay, so we will not talk about poisons for now. So assume that catalysts are generally going to increase the rate of the reaction. Okay, so the question is, how is it able to increase the rate, right? How is it able to increase the rate? I will put it in this way. Okay, so catalysts are going to provide an alternate mechanism, right? Catalyst, if you use, right? So if at all without catalyst, you will see that there is some mechanism. But if I use a catalyst, the mechanism of the reaction is going to get modified, right? So what do you mean by mechanism? Mechanism basically talks about what is the first step, what is the second step, what are the intermediates, what are the transition states, right? So all these things will be talked about in mechanism, obviously, right? So if I say that, if I say that the mechanism is getting altered, if I put a catalyst, right? If I say that the mechanism is getting altered if the catalyst is used, right? That means obviously the intermediate itself is changing, right? The intermediate or the transition states which you see in the mechanism, that itself is changing. Okay, so obviously without catalyst you would have had some intermediate, with the catalyst you would have had some other intermediate, right? So obviously what you can understand, if the intermediates are changing, or say the transition states are changing, which property would you expect to change? Are you able to understand my question?
The rate, sir.
Rate definitely, obviously, that is true. But other things, say one more thing. Because of that only rate is changing.
Sir, concentration.
Concentration. Please think in terms of mechanism. I told you that the intermediate or the transition states itself are changing.
So the bond formation and bond removal.
Temperature.
Say assume that both without catalyst and with catalyst I'm using same temperature, but still the rate is getting increased. Anything else you can come up with? So in terms of collision theory, I'll give you a clue. I'm giving you a clue. In terms of collision theory, what is that intermediate, the technical term, what is it called as?
Sir, activation energy.
Activated
Yeah,
complex.
exactly. Very good. So the thing is, if I use catalyst, I told you that the mechanism is changing. That means the transition states, intermediates, everything is changing because it is going to provide an alternate mechanism. Obviously, the only thing, or say the main reason why the rate increases is because the activation energy decreases, right? Activation energy decreases. So if I do it in the form of an energy profile diagram, right? If I do the same thing in the form of an energy profile diagram, right? Say this is my potential energy, this is my reaction coordinates, okay, right? Say I first draw the graph for a case where I don't have catalyst, okay? So I don't have catalyst, anything. Say I have something like this. So this would have been my activation energy, or say this particular thing would have been my activation energy. Okay, no problem. And this would have been the activated complex. Obviously, this is my activated complex that is having the energy of activation. Okay, right. So now when I'm going to use catalyst, this entire energy profile diagram itself is going to change. I mean, little is going to change because this is not the activated complex which is getting formed. Definitely, the activated complex which is getting formed in this reaction where I don't have a catalyst is not going to appear. It is not even going to appear if I put the catalyst, because it is entirely going to change the mechanism. Okay, so please understand that the graph, if at all, okay, the solid line indicates without catalyst, right? So if I just put the catalyst now, the energy, see, please understand, only thing which will vary is the activation energy. The initial potential energy of the reactants or the final potential energy of the products are not going to change. That ability catalyst doesn't have, right? The initial potential energy of the reactants, the final potential energy of the products are not going to change. The only thing which will change is basically the activation energy. And why activation energy is changing? Because that particular activated complex itself is not getting formed. That's the reason, right? So you will expect a graph like this. So you see here, this would have been the second activation energy with the catalyst, right? So obviously, what do you see? The activation energy has decreased. So now this would have been the activation energy. So this point and this point you compare, right? So obviously you see that the activation energy has decreased. So obviously the dotted line indicates the mechanism, or say the energy profile diagram with the catalyst. With the catalyst. So this is the reason why I go for catalyst. They'll be able to give me an alternate mechanism, thereby decreasing the activation energy. It will be asked in your chemical kinetics question also. How catalysts are able to increase the rate of the reaction? The answer is the catalyst will provide alternate mechanism, thereby they will decrease the activation energy, and so the rate is getting increased. Like this you have to answer. Okay, right? Cool. So this is only till this will, I think it will be there in your what is that, NCRT. But I can even continue with the mathematics of this. Very simple, right? So here, like last case, what you saw, temperature was changing. So the Arrhenius equation I subtracted and all that, I got log of K2 by K1 is equal to that equation I got, right? Now for this, the temperature is not changing. The only thing which is changing is the activation energy, isn't it? The only thing which is changing is activation energy. So I will be able to get a beautiful equation for this also. So how will I be able to do that? We'll see. Say I write log of K1. So K1, if I write K1, it is without catalyst. So I'll just put also without catalyst. Okay. So K1 is equal to log A minus EA by 2.303 R into T. So now it is K1 without catalyst. So obviously I'll put EA1, first activation energy. Okay. Now with catalyst, it would have become, the rate would have increased. So log K2. Now A is constant, still same. Now activation energy is changing. So obviously it would have become EA2, some value. It would have gotten lesser, obviously. So now I would have had 2.303 RT. Temperature is still, what to say, not changing. Temperature is not changing. Only catalyst is introduced, right? So now this would have been there. So if you have taken this down, you guys can have this part. Oh, I have space down, no problem. So now what I do is I subtract this by this. That is log of K2 minus log of K1, right? So log of K2 minus log of K1 would have become log K2 by K1, and log A would have got cancelled. So what I have is, so I have minus EA2 plus EA1, because minus sign will, this sign will change to plus. So I can write this as EA1 minus EA2, right? EA1 minus EA2 divided by 2.303 RT. That's it. This would have been the equation if I introduce catalyst. So EA1 is the activation energy without catalyst, EA2 is the activation energy with catalyst, and K2 and K1 are without and with and without catalyst rate constants. That's it. Beautiful equation, right? So don't worry, questions will not be asked, but you can just know, right, how the rate constant is. What is the relationship between the rate constants and the activation energy with, if I put catalysts? All these things can be calculated, right? Say sometimes what can happen is they will introduce a catalyst, right? And still the rate, the reaction rate is not that much sufficient. So what they do is, after introducing catalyst also, they might increase the temperature. Okay. So at that time, what will happen? Activation energy also will change. Temperature also will change. So now I will have a mix of this equation and the previous equation I would have seen. Now I can even easily write it. So this is what you would have got. So if temperature is increasing and catalyst is introduced, so very simple, log K2 by K1 will become 1 by 2.303 R, or I can write it as 1 by 2.303 R, EA1 by T1, EA2 by T2. Very simple. So you can see the temperature is also changing, activation energy also changing, because the catalyst is introduced. But anyways, this much and all they will never ask you. Even in JEE mains, they'll not ask you this much. Max to max, they can go to this equation. Okay, right? So yeah, that's about the chapter, guys. Okay, right? So we have completed 3 physical chapters, physical chemistry chapters. We started with, I think, solutions, electrochemistry. Then we completed your chemical kinetics. So next class I'll be taking solid state, right? Next class I'll be taking solid state, and after that, solid state is a very small chapter, okay? But the thing is, for solid state, if at all you want to study it in depth, like how you studied in other chapters, solutions, electrochemistry, and chemical kinetics, studying that in depth requires a lot of imagination, right? Because the 3D structures will come, like a lot of the holes, all these, how the packaging is done, all these things will be studying, right? So it requires a lot of imagination. But even if you don't have those skills, right, even if you're not able to imagine and stuff, but still you'll be able to learn the concepts and do the problems. That I will make sure, right? And in surface chemistry, you have 2 parts. Surface chemistry I'll be able to divide into 2 parts. First part actually talks about a phenomenon called as adsorption, AD, not AB, AD, D for dog, right? So adsorption is a phenomena which we'll be studying, right? And then you will study the types of adsorption and all that. And in second part of that chapter, you'll be studying about catalysts again. So catalysis is the second part of that particular chapter, right? So you have different types of catalysts. You have different types of catalytic reactions, homogeneous catalysis, heterogeneous catalysis, and all these things you will be studying, right? So yeah, so there are only 2 more chapters, right? But it's not necessary that you have to ask me only doubts from this chapter. If you have any doubts, you can personally text me, like even organic or inorganic coordination compounds, all these things. If you have any doubts, please do text me. I'll be able to help you, right? So guys, what I wanted to know is, now that we have completed 3 chapters, how do you think? Is everything okay? Am I going so fast, or is there any suggestions you want to give me about teaching? That, sir, this I'm finding it difficult. Like this, you can little change. I'll feel better. Do you have any such queries there? You have any such suggestions, guys?
No, sir.
No, sir.
This is
no,
not
sir.
your school. I am not going to judge you, right? So you paid the money. It's all your right to tell it, right? And
No,
if
sir,
at all I'm able to
actually,
change,
sir.
I will be able to change. Like if at all I'm able to, yes, I'll definitely do it. Right? Are you finding my teaching okay? Like, are you finding it like say easy to understand and all that?
Yes, sir.
Yes, sir, very
Yes,
much.
sir.
Yes, sir.
Right? Okay. Cool. Till then, so we'll see. Next class, we'll start with a new chapter. Please practice it. So guys, so the thing about physical chemistry is the more and more you practice, more and more you're going to become better at it, right? Do not wait for the board exam to come. Just like whenever you can see that I'm doing it very slowly. So per day, one formula, like that only we are saying. So that day itself, you can just go complete. If at all you have any extra books, or you can just call your NCERT book back itself. More than sufficient. More than sufficient. Okay, so please keep in touch with the problems, or else you will eventually forget. Okay, so fine, guys, we'll meet again. Thank you. Bye bye.
Thank you, sir.
Thank you,
Thank
sir.
Thank you, sir.